Okay, this problem is an area paradox, and you'll see why in just a moment. What you do is you take out a piece of graph paper, and I think it's important to have the graph paper showing. So you cut out these shapes on a piece of graph paper. This is a 3 by 1, 2, 3, 4, 5, 6, 7, 8. So you have a 3 by 8 right triangle here, and this is another 3 by 8 right triangle. These trapezoids, this is 5, this is 3, and this is 5. This is 3, this is 5, and this is 5. And you cut these pieces out of on graph paper so you can see the actual grids, and you ask your students to make two shapes. One is a square. See if they can make a square out of these pieces, and secondly, see if they can make a rectangle. And you can just hand out a piece of graph paper and have people cut out their own shapes, but it's probably a little easier just to have the shapes all pre-cut. So take these shapes, make a square, make a rectangle, and you can have them work in partners. There'll be a little time to see that happen. I've arranged these so that this already looks a bit like a square if you squeeze it all together. The rectangle might take a little more time, but after a while they're going to make the square. And if we look at the square, this 3 and this 5 mean that that is now an 8 by 8 rectangle, and 8 by 8 rectangle means it is 64 square units, and they can piece it together and see the 64 square units in that rectangle. Others are working on getting together a 64 units in that square. Others are looking at the rectangle. When they get the rectangle together, it ought to look something like this. And this rectangle looks great. It's a 5 by 8, and 5 make 13. So it's a 5 by 13 rectangle, which is great. And 5 times 13 is 65, not 64. So here's the paradox. We have these two shapes which are made of the same figures. The same four basic shapes were put together. One shape has an area of 64, and one shape has an area of 65, and therefore there's a 1 square unit problem here, because we know that the area should be the same by the conservation of area. When you cut things up, no matter what the shapes are, put them together in different order, they should have the same area. So I guess the question is, which of these shapes is right? Is it 64 square units that is the right shape, or is it 65 square units that's the right shape? What is it about these figures? Why wouldn't they be the same? A whole lot of questions that can be asked about this. And basically, there's certainly a paradox. Do you have faith in either of these units? Is it 64 square units? Is it 65 square units? That's the question. That's on the table, and can you explain why there's a difference? One approach as you go at it, now after a while, there is a problem in this second rectangle, and I think if you were to draw, this is what they would see. This is the picture they've put together. And let's just take a look at it. I think it's interesting to look at by slopes. If we look at the slope of this line, it goes down 3 as it goes along 8. So the slope of that line segment is negative 3/8. Excuse me. Well, depends on how you're looking at it. If you're looking at it as the edge of the triangle, then it's negative 3/8. But what happens if you look at it as the edge of the trapezoid? Well, in that case it's going down 2 as it goes along 5, because this was 1, 2, and we went along 5. So right off the bat, we're seeing, oh, these slopes are not the same. If the slope of the trapezoid, it's -2/5, and if the slope of the triangle, trapezoid, and the slope of the triangle are very different, 3/8 and -3/8 and -2/5. So what does that mean? And what's that causing? These edges, in other words, do not exactly line up, and that's what's happening. So the question now is, can you give them a piece of graph paper and have them make a more accurate layout of the shape, or work out the layout with them and see what's going on? That layout is going to look more like this. The triangle, -3/8, looks like that. That's the slope right there, the -3/8, and the slope from the trapezoid is down 2 as it goes along 5, -2/5. And you can see that those slopes are just differentiating a bit, and they get more and more broken. There's also a difference in the slopes of these two. As you go from this point here to the edge, you're traveling a slope that goes down -3 as it goes along 8. So that one is -3/8, and this one, of course, is the -2/5 as it comes down the other side. So they get, one goes sharper and then more gradual, and one goes more gradual and then sharper, depending on how you go. So this rectangle, which is 5 by 13 equals 65, is not right, and you can see that this whole area in here, if you were to fill it in, must be something that has an area of 1 square unit. If you were to take it away, you'd be back to the area of these 4 figures adding up to 64. So the 4 figures add up to 64. You could do that by looking at the original and find the area of these 4. The area of 2 triangles plus the area of 2 trapezoids is going to equal 64 if you just look at these original figures. The square is 64, but this figure, the rectangle, has an extra 1 unit, which is a very stretched out, strange 1 unit. Interesting problem, worth looking at.